Hello, and welcome to Electronics 101. There doesn't seem to be a lot of information regarding Clockkeeper's automation and electronics online, so I thought I'll make a video to cover up on this subject. This video is gonna be a bit different from our Quick Info series on my channel. The Quick Info series aims to give you guys as much information as possible within the shortest amount of time. The reason why it's gonna be different is because I believe this video will require me more time to explain how certain component works and how they work well together. So without further ado, let's get started. Once you have crafted the iron workbench, you can craft the electronics table. And once you have crafted the scarlet workbench, you can craft the automation table. These are the two tables that contains the buildings and components that we'll be using in this video today. First up, we have the electrical wire. Not much about it. You can combine components together with the electrical wire and it will send power course through as long as it's connected to a generator. Next is the generator. It makes this really loud buzzing noise, but if you stand 3 tiles away from it, you can't really hear it anymore. Generator is going to be the key to powering up all of these electrical components that we'll be talking about today. Next we have the lamp. The lamp will require a power to light up. So if we use the electrical wire, connect it to the lamp, it will light up. The cool thing about the lamp is that you can color code it. So you can make it blue, green, red, purple, and many other colors that I won't be touching on today. Using these 3 components, we're going to touch up on how the electrical generator actually works. So there doesn't seem to be a limit to how much power the generator can supply. In theory, you can place like a bunch of lamps around it and it should all power up. What affects the brightness of the lamp is the number of tiles it is away from the original source, which is the generator. So you can see around 8 blocks, the brightness starts to become dimmer, and around 14 blocks there is no power to light up this lamp. If I just break this block here and place a lamp here, you can see that it is the 14th tile from the generator and hence this one will light up. But if we move up 1 block, it's the 15th tile. And it's not about the distance because this lamp here is about 3 tiles away from the generator. And because it's connected by a copper wire, which is a really long tiles away from the lamp itself, it will not light up. But if I connect it directly like this, it will light up really brightly. If you want to extend the power source from the generator over there continuously, what most people would think to do is to put a generator here, but this also lights up in this direction. So you want to remove this and replace it with a logic circuit and then a generator right below. You get this really finicky effect here, which I'll explain later on. So let me just remove that for now. But you can see that it's actually working. It's now one direction. It starts to get dimmer here, but then it boosts up, and then there's a light over here. So that's pretty much covers the generators. I'll explain what you saw earlier, the finical thing, when we touch up on loops. But first, coming back here, we are going to go through all the remaining components. We have the lever, which is pretty much a switch. It stops the current from going through, and when you flip the button, it sends the current through. Next, we have the electrical door. If we send a current to the electrical door, it should open. I crafted these scarlet walls here because I thought, hey, it's metal. Maybe it can send like an electrical current through the wall itself. So I tested it out and it does not work. But wait, look at this. Somehow this one opened. That's because underneath this scarlet wall, we have a wire. So a really cool thing is that you can place walls on wires and they will still flow through. Any kind of walls will work. But you can't place the wire on the wall itself, so you need to dig it up and then place it down and then place it back again. Next up, we have the delay circuit, which delays the current from flowing by 1 second. It's stated in the description itself. So you can go up to it and press E to rotate it. There's 3 inputs and 1 output. The 3 dots is where the output is at. And then we have the 3 inputs at the other 3 sides. So let's face it towards the lamp. And then we'll dig that up. We'll connect it around like this. We flip the switch back off. So we can put it here, this is 1 input, or we can combine it here to the 2nd input, or like the 3rd input over here. It doesn't really matter. But let's just do it this way. When we flip the switch, after 1 second, it lights up. It's a bit weak. I think it's because... There we go. I think it's because of the number of tiles as mentioned earlier from the generator. So if we reduce it by 3 tiles here, or 2 tiles actually, and it will be much stronger. So next we have the logic circuit. The logic circuit is pretty fun. It is basically your AND and OR gates. You have your output on the top where the arrow is pointing, and then the 3 inputs at the side, similar to the delay circuit. So how this works is if you send 2 currents into the logic circuit, it will power up whatever's in front of it. So let's put this generator. Do we have a generator? Let's grab this generator here. Then we'll put it right here. So now it's currently sending 1 current through, and it will not send anything out because it requires 2 power into 2 of its inputs. So if we do it like this, you can see that this will light up. And if we send 3 currents into 3 inputs, it will not light up like this. No signal will send out. We'll combine this with the electric stake, which is this item here, the electricity stake. It will change its behavior to something quite unique actually. If I place this right next to it, there is an output, sends out an output. That is because the electrical stake changes the behavior of the logic gate. It does nothing on the delay circuit as far as I know, but on the logic circuit it inverts the conditions. So instead of having a requirement of 2 power sources into the circuit to send out an output, with the electrical stake it now requires only 1 power source. And an interesting thing, if you now add a 2nd power source, there will be no signal. So this is the cause of the loop that we will touch up in a second, in a few minutes actually. Next up we have the conveyor belt. Unfortunately, the conveyor belt doesn't have any electricity flowing through it. It just works normally. Even if you combine it to the wires, place it next to a generator, nothing will happen. It won't stop. It will just continue moving. Same thing for the spike trap. Even if you connect it here, nothing will happen. It doesn't go up. So unfortunately, we don't have any cool death traps we can make from mobs with some kind of electrical mechanism behind it. Next up, we have the drill. So the drill, you can rotate it around. It's used for mining the boulders. Probably in a separate video if required, but I feel like there's enough information of how to mine a boulder out there. But if requested, I can also make this video for you. And if you connect it to the power source, it starts drilling. A really cool thing about the generators and all of these components that I failed to mention earlier is that you don't actually need the copper wire to power them up, to connect them together, because it itself will allow current to flow through, as you can see here. So same thing with the drill. If I put another drill next to it, it works just as well. You don't need to waste any wires behind it or on it to power it up. So this was a rookie mistake I made when I first started out. Next up, we have the mechanical arm. Oh, I forgot to mention the drill over here. So you can use the drill to actually drill up the dirt wall, which kind of takes a little bit of time. And I kind of tried it with this scarlet wall as well. It's even worse. Let me just put it in the background to show you guys. It takes like a few seconds and you'll dig through. Most very inefficient. You might as well just use your pickaxe. Also, you can't. It's not mobile, so there's no reason to use this. Other applications for the drills probably include like gardening, wood farms, and all that. I have covered wood farms in my quick info video. You can check it out. I just uploaded it quite recently, actually. Anyway, moving on, we have the mechanical arm. Let's get rid of that because that's a bit dangerous. You actually can take damage if you stand in front of the drill for too long. Okay, bad angle maybe. There we go. So let's get rid of that. It also destroys blocks that it's facing. So it destroys the drill that it's powering itself as well. Okay, mechanical arm. What is cool about a mechanical arm is if you connect it like so, and you drop an item in front of it, it picks it up and tosses it behind like it's trash. And we have some mechanical arms here to kind of display this. Most people, what they will do is after drilling the boulder, they will have the conveyor belt send the ores into the smelter with the mechanical arm. So like the let me show you quick example. That was a bad placement. Quick example like this. We put the mechanical arm here. Okay, no, it's a bad angle actually. Mechanical arm like that. So we'll power this like that. Oh, it's not connected. Okay, so now this is powered. If we put copper ore, imagine there's a conveyor belt leading straight down like that. It will send it into the smelter here, and once it's finished smelting, the bar will go into the chest. So this is what normally people use the mechanical arm for. And I actually made like an accidental discovery because I had it flipped the other way. So let's wait for it to finish smelting in a second. And so I had this arm flipped the other way, and it actually picks up item from the chest and tosses it into the smelter. And I think it doesn't discriminate. It's a container of its own, so it can put whatever things you normally wouldn't put in. So that's how I discovered that you can pick things out from a chest and actually transfer it into another chest. Here we go. So where we put in the stick and the slime. And so I thought, hey, what about the pedestals? Okay, so we put a pedestal, an item on a pedestal like that, and we powered it. It will actually pick it up and put it behind. And the same goes for the flower pot. And I thought, okay, this might be something we can use. Unfortunately, torches don't light up on the pedestal, but glow tulips do on the flower pots. So later on, I will show you a really interesting design with this mechanical arm and flower pots. But first, I want to show you something else, which is this item that you get from killing the bosses. It's a legendary item. I think all the legendary items have the same sound effect when you drop it, as so. It makes this really nice shing sound. And so I thought maybe we can do something with this. And if I just dig this up, okay, thank you for putting it there. Drop it in front of the thing, and it drops. It picks it up, it drops it behind, and it makes a sound. What happens if you have a whole row of mechanical arms just picking up the legendary item and dropping it? It will make a chain sound effect of the legendary dropping. So that's something you can think about as I move on to the next thing. And the next thing is loops. So how do we make a loop? You need a logic circuit powered by a generator. Then if you put a copper wire in front where the power source is, it wouldn't light up, right? But if you use a electric stick, it will light up. So the question is, what happens now that you have one power source with the electric stick changing its behavior, what happens if the output goes back into the input? And this is what happens. It creates a loop. So what's happening here is the power source is going into the logic circuit. As usual, it will power up everything and then it goes back into the input. But because of the behavior change, if you have two inputs of power sources, it will stop giving out a signal. And the moment it stops giving out a signal, it's back to having one power source. And then it gives out another signal. And so it keeps going on an infinite loop. And that's why you have this really finicky thing that you saw earlier on. Interesting thing about the electric stick is you could actually replace this with two copper wires and it will still net you the same result. That is because we are also producing a third input over here. It doesn't matter if you use the stick or not, but this is how the behavior of the loop works. Congratulations, you have made the first loop. Now, we want to control this really finicky, like infinite loop here. How do we do it? And the answer is with delay circuits. So let's get rid of one of this copper wire, and then we'll rotate this, and now we have a nice loop that goes from left to right. And if we put some lights here, and we have our paintbrush, color this blue, color this red, congratulations, you've made your second loop with a siren. And this pretty much covers all for loops. What interesting things can we make with loops here? So I thought, hey, why not a rotating light show like this? The idea is to use the delay circuits to power the next light, and while this is happening, it sends the input back into the logic circuit, which will power down the first light. But this is taking too long, such that, you know, the first light is still dimly lit by the time it gets you know, powered up again. So this is a work in progress, but not really what I want to show you guys. Actually, what I want to show you guys is, if you remember me telling you guys about this sound here, I talk about what happens if there's a arm just picking up this item and dropping it behind him. What kind of sound would it make? And we have this device here. Alright, this is in the wrong direction. So the direction of the arms do matter. Okay, give me a second here. Let me just fix this real quick. Okay, so now we drop this here. It lights up, drops it there, and drops it there, and brings it back here. And it stops. So that's the first version of this really interesting sound effect that we made here. What I'm trying to achieve is a continuous loop where it just keeps making this sound. You may ask why we're using delay circuits, and that's because if we normally have it all powered up like so, and where is my generator? I did not pick it up. And we put it here, it would just keep dropping and picking up the item immediately, so it doesn't make the sound effect at all. And that's not what we are trying to achieve. That was a very rare occurrence, but yeah. So that's not what we are trying to achieve. And so I made a bigger design here. Let's grab this. I made a bigger design here because I wanted to use the flower pots in the center here, and there is no space for me to put. I can't put flower pots on the circuits. I can put things on the wires, but I can't put dirt walls or torches on circuits. So that's something to take note of. And if I put the glow slip in here, so this is a bigger version of that, except now we have a loop that's outside the circle, and it doesn't loop back into the logic circuit. It just stops here. So before that, I was racking my brain on like how do I time this right such that it will just start the loop immediately. The problem was I had the logic circuit right here, and then it will power up the logic circuit, and then it goes back up here. It didn't have this thing here, right? So it goes up here, and then goes here, and then once it hits here, it will power down the rest. And because of that, this thing is not powered up to react to the item that's being dropped in front of it. So with that, we had to remove the circuit right in where I'm standing, replace it with nothing actually, and then we just make the loop outside, and eventually it works. So this is the light show that we can use with the glow tulip. Unfortunately, pedestals didn't have any functions, unlike the flower pots, so this is pretty cool. Not sure what you can do with this. It's probably better rotating than the lamps at the moment. And so moving on to this really cool sound effect, we have made a compressed version over here. Let's drop it down here. It's basically the same thing as the flower pot one, but it's much smaller because we don't need to put anything on the tile here. And once we light it up, give it a while. Now it's continuous. So the first time it powers up, it doesn't really work well, but now that it's powered up, it just keeps going. Alright, let's stop that. So the idea here is that now it stops sending an input back into the loop, and the loop can just go on by its own. And by the time it reaches over here, the crane is actually powered up. So that sums up loops and what interesting designs you can make with it. Next, I want to share with you an interesting discovery I made. So originally, if you combine it like this, you have this really quick blinky lights over here. But if you set it up differently like this, using an electric stick, and instead of going the right side, I discovered this by accident, where I accidentally placed a wire underneath the stick. And you can see that the behavior of this is slightly different from how it's normally blinking. It's like much slower and at random intervals. I'm not sure if it's because it's early access or maybe this is an intended feature, but rejoice, at least it's something cool that we can play around with, because I have a really fun idea that people can do with this, which is over here. I connected it to a door into a dark room with a lamp in there with moldy ground such that there's smoke coming out, so it looks really spooky. And yeah, I thought it gives like a really nice spooky vibe for Halloween, and we can do, if the creative can do something interesting with this. The last thing I want to cover is that you can place stone floors, paintable floors. Ground slime works as well on top of the electrical wiring to kind of cover it up if you think it's too ugly. But honestly, I can't think of any application for